So coming on to section 2.5, and we're looking at discriminants of quadratics, and we're going to think about it this way. If f of x is a quadratic function, then that's something that looks like ax squared plus bx plus c, and the graph will look something like this. It'll be a U-shape. Now, it could be that that U-shape looks like this, okay? Now, the roots of the quadratic are where the function crosses the x-axis. So these points here are the solutions to the equation 0 equals ax squared plus bx plus c, okay? So over here, if I want the solutions to the equation 0 equals ax squared plus bx plus c, then I just look at where this graph crosses the x-axis, except this graph doesn't cross the x-axis. This graph's floating up here, and there's no point where the graph crosses the x-axis. So this equation ax squared plus bx plus c for this function doesn't seem to have any solutions. And the other option, which you may be familiar with, is where you get this, what we call a repeated root, or just one root. We have there's only one point where the graph meets the x-axis. So 0 equals ax squared plus bx plus c. The equation which is related to this function looks like it's only got one solution. So from the graphs, thinking about functions, we can see we might have two solutions to a quadratic, which we're used to. We might have one solution, and we might have no solutions. So surely algebraically, we should be able to see that as well. And maybe it's no surprise by now, but we can. Look at the formula. If we start with 0 equals ax squared plus bx plus c, then x equals this. We've got a formula. It's always going to work, right? You substitute things in a formula, we're always going to get an output. So how on earth can we have a quadratic where there are no solutions? And the problem is this part here. So we've got b squared minus 4ac, and we've got to square root it. Now, if you square root a negative number, you're not going to get an answer. Now, for those people that are going to go on and do further maths, let's just clarify that a little bit. We're not going to get an answer which is on the real number line, okay? And if you don't know why I'm clarifying it, for the moment, don't worry about it. If you square root a negative, you're not going to get an answer. Because if you square a number, you always get a positive. So what number was it that I squared? Well, if you get a negative answer, there isn't one, right? So b squared minus 4ac, that is what we call our discriminant. If you look at the discriminant, if it's negative, then there's no way of finding these numbers here because we can't calculate that part of the equation. If it's equal to 0, then there's only one square root. 0 only has one square root, so that will be a quadratic where you've only got one solution. And if the thing's positive, it doesn't have to be a nice positive number, but if it is, if it is positive, then I can have two square roots, a positive one and a negative one, okay? So, b squared minus 4ac is the discriminant. It discriminates, it tells the difference between quadratics with two solutions, one solution and no solutions. If you take those quadratic equations and you turn them into functions by getting the expression and putting it equal to f of x, and you plot that on a graph, one solution looks like this, no solutions looks like this, two solutions looks like this. And obviously you can have the same thing upside down. I've drawn, and you can see this in the book, so there's no point in me drawing it out again. I've drawn the situations where the coefficient of x squared, the a, is positive. Upside down, it goes the other way around, okay? For all of those things, you can be asked to find the maximum and minimum values of y, which you would do by completing the square. For all of those things, you can be asked to find the y-axis crossing point and the x-axis crossing points, if there are any. To find the y-axis crossing point, put x equal to 0. To find the x-axis crossing point, put y equal to 0 in the equation. And that's all the theory that we need to know about the discriminant. I should just point out that they ask this kind of question an awful lot, which is, so x squared plus 4x plus k equals 0 has two distinct real roots. So what can you say about k? So what you do is you look at the discriminant, b squared minus 4ac. A is 1, b is 4, c is k. Substitute those things in, and you end up with 16 minus 4k. Now, if it has two distinct real roots, then those that value, 16 minus 4k, the discriminant has to be positive. So 16 minus 4k is greater than 0, and that tells us eventually that k has got to be less than 4, okay? And similarly, we're looking here at equal roots. So I think that's everything that we have to say. I should just put a note in, though. This idea equal roots, or a repeated root, is a slightly odd one. And the idea is it's a quadratic. It's got an x squared in it. And because it's got an x squared in it, and because they usually have two solutions, we kind of want quadratics to have two solutions. So when we've got a function like this, the roots, there are two obvious different roots, and we sort of think of it as like this, that if we sort of shifted that quadratic up, those two roots get closer together and closer together until eventually they just sort of melt into one root. And so rather than calling it one root, we say, well, the root from this sort of branch and the root from this branch have kind of come together and coalesced into one point. So that's where the vocabulary comes from, that we call them equal or repeated, because we want to think of it as it having two roots. We want to think of the quadratic as having two solutions, and we say, well, those two numbers happen to both be the same, so we'll call it repeated. So if it says equal roots or repeated root, it just means one root, okay? Equal solutions, repeated solutions means one solution to the quadratic. So that is section 2.5.